Hi, I'm Jonique Roland, the director of the Center for Freeform Optics. I'm excited today to give you an up-close look at the emerging technology of freeform optics featured in a new publication of Light, Science and Applications. It is our vision that freeform optics will transform optical technologies of the future. Now I will let Jacob Reimers, one of our PhD students in the Center for Freeform Optics, go into more detail about his research that exemplifies why this technology is so important today and for the future.
We've designed a spectrometer that is 5 times more compact in volume than current technologies, and in order to achieve this, we used a special type of optical surface called freeform optics. A spectrometer is an instrument that will measure the intensity of light in an image, and it will tell you how much of each wavelength you have in an image. For example, you could, when looking at a leaf, be able to tell how much chlorophyll is in the leaf, and that could give you more insight into how healthy the plant is. Traditional rotationally symmetric optics were trapped in this barrel geometry, and freeform optics, by removing the constraint of being rotationally symmetric, we're able to design in full 3-dimensional volumes. And so we take a very long telescope and we're able to fold it up and use freeform optics in order to achieve the same high resolution, but in a much smaller form factor. And in fact, we're just beginning to scratch the surface of what's possible with freeform optics. The past 3 years, I've been working with Professor Roland as a student in the Center for Freeform Optics, and my project has been to see how freeform optics, what applications we can use them in. And my work with Dr. Kevin Thompson, who I started working with after he had about 30 years of experience in industry, we worked together, the 3 of us, to arrive on this application space of spectrometers, which wasn't necessarily something that has been researched too much, and we were very interested in the potential possibilities that freeform optics could have in this design space. In this emerging field of freeform spectrometers, we could see them being used to make, for example, instrumentation on satellites that we're sending to outer space. We can make them smaller, lighter, we can send them deeper into space, or we could have additional instrumentation space available on the satellite in order to learn even more about the universe. So in the future, we could see these being used perhaps in your cell phone or in another handheld device that you carry around with you everywhere. We're very excited about the potential applications for this research, where it leads to in terms of going from something that we've developed in the lab, kind of more as a demonstration, to more consumer products and how that will affect and shape the future.
The technology promises to deliver sensors, mobile displays, and a host of other devices that are not only smaller, lighter, and expected to be less expensive, but also outperform those containing traditional lenses and mirrors. Imagine that from improved satellite imagery to more precisely matching the paint in your living room, spectrometers are used broadly to monitor the environment, help diagnose diseases, and span a wide range of other applications. That is the power of freeform optics.